Welcome back. Today we're going to continue our study of polyhedrons and solids by taking a look at some pyramids and cones. Now, just like before, what we're going to be doing is we're going to be looking at volume and surface area for these three-dimensional solids. Now, I've got a pyramid here. Now, pyramids are examples, as you can see, of polyhedron because all the faces are made up of polygons. In this case, we've got a rectangle for the base down here at the bottom. We've got these four lateral faces, the sides, which in pyramids will always be triangles, and they come together at the top to form what is commonly referred to as the apex of the pyramid. When we're finding volume for a pyramid, there's a very convenient formula that we're going to use. The volume of any pyramid is always 1/3 the volume of a prism with the same dimensions. We saw before that a prism, you'd find the volume by taking the area of the base times the height. So for a pyramid, the volume is 1/3 the area of the base times the height. That's true for any pyramid rather. That's good for this rectangular pyramid. If the base was a hexagon and it's a hexagonal pyramid, just as good. So let's get some dimensions on this pyramid and see what we can do with volume, and then we'll move on to surface area. So let's say the base is 4 by 10 centimeters, and the height of our pyramid, which the height of a pyramid is always defined as the distance that the apex is from the base. So we're going to have this perpendicular distance. That is going to be the height of our pyramid, which in this case, let's make, 18 centimeters. So to find the volume, we take the area of the base, which in this case is going to be 40, and we multiply it by 18, and divide the whole thing by 3. So we get a volume for this pyramid that is 40 times 6, so 240 cubic centimeters. Now on to surface area. So surface area for polyhedron is always the same. So just like with prisms, all we need to do to find the surface area of the pyramid is find the sum of the areas of all of the different faces. Now for the base, that's pretty straightforward. We already found the area of the base in our volume calculation. Where things are going to get tricky is with these lateral faces with the triangles, because the heights of these triangles is not the same thing as the height of the pyramid. Because the sides of the triangles are not perpendicular to the base, the triangles are slanted. So what we need is what's called the slant height or the lateral height, which I'm going to call L. I'll call it L1, because these different faces are going to have different slant heights. These triangles are not all congruent. Had the base of our pyramid been regular, like a square, then all of the triangles would be congruent, so all the slant heights would be the same. But this 4 centimeter base is going to have a different slant height than the 10 centimeter base. So I'm going to have multiple slant heights that I'm working with here. I'll call that one L2. Now, to find these slant heights, I'm going to need to get a little bit creative with some right triangles that are sort of intersecting and inside my pyramid. First, with L1. So I've got a right triangle, the base of which is going to be 5 centimeters, and the height is 18 centimeters. So I can use Pythagorean theorem to get L1. In this case, L1 is going to be equal to the square root of 349, which is going to approximate to 18.68 centimeters. For L2, we're going to do the same thing. I've got another right triangle drawn. With L2 as the hypotenuse, the height is still the 18 centimeters, but this time the base is going to be 2 centimeters. So in this time L2, again I'm using the Pythagorean theorem, 2 squared plus 18 squared, is going to give me 328, so L2 is equal to the square root of 328, which again I'll approximate to about 18.11 centimeters. We now have all of the information that we need from our calculations to set up our sum for the surface area. So we'll go ahead and we'll take care of that. So the surface area is going to be equal to the sum of the areas of all of the faces. So we'll start with the base, which has an area of 40. Then we'll bring in the triangles. Now I've got two triangles that have the 4 centimeter base. So 2 times the area of that triangle, which is 1/2, times the base, times its height, which was L1. And I've got two triangles with a 10 centimeter base. So again, I've got two of those, half the base times the height. We can sort of simplify things a little bit here. Run this through our calculator, and our surface area is going to approximate to 295.83 square centimeters. Hooray! And there we have pyramids. So with that, let's take a quick look at cones. Gotta get this over here. There we go. So I have a cone. Now cones are pyramids in the same way that cylinders were prisms. They behave in the same way, we can treat them the same way. The only difference is that a cone, just like its cylinder counterpart, was not a polyhedron because of the circular base. Other than that, all of the rules for pyramids that we just talked about are going to apply. That begins with the volume. Volume is still area of the base times the height divided by 3, just like with pyramids. So if we were to define a few things here, let's say that this cone has a slant height of 13 feet and a height of 12 feet. We could use that to find its volume. We just need to find the area of the base, which means we need this radius of the circle. We can use Pythagorean theorem. Well, don't really need to. It's going to be 5. 5, 12, 13 is a Pythagorean triple, so don't even need to worry about calculating it. So let's find the volume real quick. Volume is going to be the area of the base, which is going to be 25 pi, times the height, which is 12, all over 3. Which is going to give us a volume of 100 pi feet cubed. I'm just going to leave it in terms of pi. Now for surface area, we do have to worry about how we're going to calculate the lateral area. Again, that sleeve that sort of wraps around the edge of the cone. Because we don't have triangles to work with, we need a formula that's going to tell us that. Now the good news is the lateral area for any cone, lateral area for a cone is always going to be equal to pi times the radius times the slant height. So pi RL. Putting this together with the base, which is always going to be a circle, the surface area for a cone can be written as pi r squared, area of the base, plus the lateral area, pi RL. So putting the numbers for this specific cone into that formula, the surface area is going to be equal to the area of the base, which is 25 pi, plus the lateral area, which is pi RL, so 13 times 5, 65, so 65 pi. These are like terms, so we can add them up. Our surface area is going to be, 90 pi feet squared. There you go. Pyramids and cones. Not much to them. Volume, always got to remember, is 1/3 the value of a prism or a cylinder with the same value. So area of the base times the height divided by 3. Divided by 3, very important for pyramids and cones. That's all I'm going to leave you with today. Thank you very much. Good luck and have fun.